Hi and Assalamualaikum. So project ECS246 will present about sustainable of glass. The research objective of the three articles that we find is the sustainability of waste glass as a replacement of fine aggregate.
Hi, Assalamualaikum. This is our team member. First, my name is Nur Amira Syafika binti Abdul Hamid.
Hi, my name is Nur Afika Shamimi binti Daniel Hakim.
Hi, my name is Nur Fatia Nabila Rahman.
Hi, my name is Nur Badrina Nabila binti Zrizal.
Table of content, we have introduction, methodology, results and discussion, conclusion, recommendation, and lastly, reference.
Glass is one of the most widely used material with uses as diverse as building construction, used in containers and vessels, automotive windows, and nanotechnology applications like as optical fibers. It is appealing for a variety of reasons, including its transparency, chemical inertness, environmental friendliness, sustainability strength, ease of availability, and low cost. The use of glass in the construction of well-lit and expensive buildings has grown in popularity. So the objective of the article is to discuss the evaluation of the compressive and splitting tensile strength of concrete mixtures containing different proportion of up to 20% gases aggregate. Portion of sand in concrete with and without admixture were replaced with measurement of glass aggregates. The first method that we use are slump cone. Slump cone are to determine the workability of the fresh concrete to ensure the uniformity of a mixture under field condition. The test carried out using a metal mold in the shape of conical that filled with fresh concrete mixture in a 3 stages layering. The slump of the concrete is measured distance from the top of the cone until the top of the slump. Second, compressive strength is to determine the maximum capacity of the concrete to withstand loads. The test carried out using standard sample 150 millimeter cubic hardened concrete by compressive machine that being pushed together. Third, flexural strength used to determine the flex or the bending properties of a material. The test carried out in a 3-point bending setup with a beam 100 mm times 100 mm times 500 mm and 40 mm times 40 mm times 160 mm. The nominal distance between the support was 300 mm. The roller allowed for the free horizontal movement. Last method that were used are split tensile tests was tested on a cylinder-shaped sample with 100 mm diameter and 300 mm height. This method to know the maximum the tensile strength of a mixture by stretch the concrete until reach its limit.
The first one, we have the results from Table 5. Table 5 shows us the result obtained for its material and mechanical properties. The presented values are average values of 10 samples for each mix. From Table 5, we can know the results of the pressure pour test of mortar mix. Next, it shows the test result of 28 days compressive strength for sample with the addition of glass aggregate. Moreover, the results of the flexural test samples with glass sand aggregates as replacement for sand is also shown in Table 5. Lastly, it shows the result of split tensile strength for samples with addition of 5%, 10%, 15%, and 20% weight percentage of glass sand aggregates. Result for slump test. Figure 6 shows the addition of glass cullet to mortar reduce its workability, except for a mix with 5% glass cullet. For the 10% and 20% weight percent of glass cullet, the slump cone decreased for about 40% compared to the base mix. Table 4 shows results of slump test cone. which is between 20 mm to 40 mm. The air content of the mortar mix with the fine glass aggregate was between 1.8% to 2.4%. Next, result for compressive strength. One of the most significant features of hardened concrete is its compressive strength. It is the most important attribute for determining concrete quality in relation to established technical standards. Figure 8a shows that the compressive strength increased linearly as the glass sand content increased. With the addition of 5%, 10%, 15% and 20% weight percent of glass aggregate, the strength increased to 11.3%, 17%, 24.5% and 28.3% respectively. Results of flexural strength. From table 5 that has been shown before, the flexural strength increased as the weight percent of the glass aggregate increased. Figure 8a shows the linear correlation between flexural strength and glass sand concentration. The addition of 5%, 10%, 15% and 20% weight percent of glass sand aggregate flexural strength increased compared to the reference sample by 2.9%, 7.6%, 9.5% and 14.3% respectively. Lastly, result for split tensile. Figure 9 shows the linear relationship between split tensile strength and glass sand content. The addition of 5%, 10%, 15% and 20% of weight percent of glass sand aggregate increase in split tensile strength compared to the sample was 19.7%, 20.9%, 21.8% and 22.8% respectively. The difference in strength for the reference sample and the sample with the lowest addition of glass cullet was significant. Discussion from these experiments. As we can see here, figure A and figure B are from one article and figure C and figure D are from another one article. When analyzing new materials, it is necessary to figure out how the right mechanical characteristic relate to one another, with compressive strength being the most significant by design mechanical parameter. Figure A presents the relationship between compressive strength and flexural strength. The pattern developed by Lin and Poon. Lin and Poon obtained strengths lower compared to the base mix, and they determined that the flexural strength was found to be about 1/4 to 1/6 of the compressive strength. Next, figure B shows the correlations between other mechanical properties, such as compressive, flexural or split tensile strength of mortar with glass sand aggregates addition. The obtained mechanical properties of mortar containing glass sand aggregates and reference sample, which is without the glass sand aggregates, were different. Then, figure C shows the variations in compressive strength with H for the control mix and the mix containing 5, 10, 15 and 20% of glass aggregates as a trial replacement for sand. It also shows the comparison between the values of compressive strength for the same mix. Lastly, figure D shows the splitting tensile strength for all the mix after being cured for 3, 7, 14 and 21 days. There was a significant increase in splitting tensile strength for all of the mix with the age due to the process of hydration that reduced permeability and improved the transition zone.
In conclusion, glasscrete was just as speedily as traditional concrete because concrete is a compression member but not a tension member. Next, glasscrete meets the fine glass aggregate replacement up to 20% did not cause a reducing in the compression strength. Furthermore, the use of glass aggregate as a volume replacement for sand decreased the fresh and air dry density. Glass aggregate was used because its specific was lower than sand, which was higher than sand's geologic gravity. For the first recommendation, each of the research work achieved the objective well, which is the glass can be regarded as the most suitable as a fine aggregate due to the physical properties. However, the weakness is the use of excess amount of waste. Glass will let the fill of any concrete structure and will refill concrete grade in structure. Next, the influence of addition of a glass sand aggregate for improved medical properties of a concrete has really been reported.
Knowledge gaps that were still unsolved in this research is the relationship obtained in this study were rarely found in the literature. Therefore, they should be verified in further tests taking into account other glass sand aggregate contents, its particle size, and in relation to the resulting alkali silica reaction. It seems that the increase in mechanical properties of concrete with the addition of glass sand is probably resulting from the pozzolanic activity. This will be the subject of further research in which tests for other types of cement, other types of glass waste, and its mix and different contents and the size of the aggregate particle, with particular emphasis on long-term fatigue tests are planned to be carried out.
I would recommend the new inventions of glass as a structural member replacements of a metal beam and column. The structural load is reduced due to the lightness of the glass. Glass has following characteristic, which is a visual porosity, aesthetic, rust resistance, and insulator of electricity that is suitable as a structural member. Because of its transparency, it's like the most natural light, resulting in a lower electricity consumptions. Furthermore, size and scales are critical considerations for the future use of a glass as a structural material. Larger sizes with smaller support sections are very popular. These allow for a longer span, which can be used in a tall building to withstand the wind pressure. Glass can be versatile building materials due to its demand for recyclables, self-cleaning, fire resistance, and heat insulating materials. As a result, the future development of a glass as a structural material has a very high potential. With technology progressing at such a rapid pace, it will soon be structurally sound to use at large scales and a volume. That is all from us. Thank you. Bye.